In this example, we're going to look at how to calculate a derivative and how to compare the graph of the derivative and of the original function. Let f of x equal 2x squared plus x. Part A, we'll find the derivative, f prime of x. Part B, we'll graph f of x and f prime of x, and we'll explain their relationship at x equals -1. Okay, let's get started with part A. Here's the original function again, 2x squared plus x. And right below that, I'm going to be calculating and writing f prime of x. The first thing to look at is the power of 2 on top of the x. That's the most important part of this calculation. And we're going to bring that 2 down in front of the other 2. And we'll multiply the results together. So it'll be 2 times 2x, and then there'll be a new power on top of the x. I've got a question mark there right now. The new power you would get by starting with the original 2 and subtracting 1. So it'll be x to the 1 down below. Okay, and now we'll do something pretty similar for the next term in this function. So it'll be plus, and then we need to look at what the power is of x up on top. What is that power? I didn't write it. Well, if you don't write the power, it's usually assumed that it's the power 1. And so the number 1 we'll bring down in front, and we'll multiply that by x to the question mark. What would be the new power of x? Again, we subtract 1, so it's 1 minus 1. That would be x to the 0. Well, almost always we would simplify and rewrite this formula for the derivative. We've taken the derivative now, but we'll clean it up a little bit. And so we'll write it as 4x plus 1. We don't usually bother writing x to the 1, and we don't usually bother writing x to the 0. Okay, so that's part A. Now let's look at part B. We're going to graph the original function and the derivative and compare them at x equals -1. I'm not going to talk a lot about how to graph these. You could use your calculator or a computer. Probably we could do it by hand as well. It's a straight line for the derivative, and it's a parabola for f, and we should be pretty good at graphing those. In any case, here's the picture. So we have f prime is the straight line, and the parabola is f. And we want to look at one pair of points on these graphs, the points where x equals -1. So I'll mark them. The red point is on the parabola, and the blue point is on the straight line. If you look at those, it may not be obvious that there's any relationship between those 2 points. One is above the x-axis, one is below, they line up, but it maybe is hard to see how the graphs are related. What you need to do is think a little more about the information at these points. In particular, we need to look at the y value for the blue point on the straight line. The y value there is -3, and that's related to something with the red point on the parabola. It's related to the slope of the tangent line. And so I've drawn the tangent line in red, and in fact the relationship is that, do you know it? They're equal. So the slope of the red line is equal to the y value at the blue point. Let me just go ahead and summarize that in writing, because it's a tricky relationship and it's important to get it right. So here's the summary. The y value of f prime of x at x equals -1 equals the slope of f of x at x equals -1. So it's the y value for the straight line compared with the slope of the parabola. And that's the end of the example.